All right, today in class we learned how to solve for a specific variable, and this is in 3.8. Our objectives, the first one is to solve for a specific variable in an equation, and the second one is to find the perimeter and area of a trapezoid. Okay, so I'm going to give you some steps on how to solve for a specific variable. The first step is to identify the variable needed to solve for, and to try to find where it is in the equation. If you need to circle this, that's always a good thing, so that you can identify where it is and which one you're looking for. The second step, if the variable is listed multiple times, so for example, if you're looking for x and it's on both sides of the equation, you need to move the smaller of the two to the other side. Your third step, it says to move all other values and numbers not attached to the specific variable to the other side of the equation. And this is going to happen by addition or subtraction first. Then the last step says to isolate the variable either by multiplication or division. These are similar to the steps that we had when we were solving for a variable, for only one variable in an equation. You're going to see multiple variables in your equations today. So our first example, it says to solve each formula or equation for the variable specified. On the first one we have a equals 1/2 hb, and that semicolon b means that we are solving for b wherever it is in the equation. So you're going to look to find out where b is in the equation, and it's right here. And I'm going to go ahead and rewrite this formula. It's a formula, if you remember, this is the formula for a triangle. And whenever we see numbers, we want to try to get rid of those numbers first. And you want to look to see how everything is attached. They're all attached by multiplication. So because they're attached by multiplication, that's what those little dots are, then we want to do the opposite of multiplication, which is dividing. However, when we have that fraction, if you see we have that 1/2, we want to get rid of it, and I like to use our math swear word. That's our flippin' times. So we're going to take the 1/2 and multiply both sides by its reciprocal. We're going to flip it and times. That's where that flippin' times comes from. And then whatever we do to one side, we have to do to the other. So at this part of our equation, the 2's on the right side, the 1/2, and the 2/1 will divide out. And on the left side, you're just left with 2/a. You don't need to keep that 1 there. Is equal to hb. Now again, our equation said that we wanted to solve for b, so we need to get rid of that h. They are being multiplied, and we have to do the opposite of multiplying, which is divide. So we're going to divide just using the fraction line right there. Whatever we do to one side, we have to do to the other. This will isolate the b on the right side because these h's will divide out. You'll have a b equals 2a over h. Now, even though this isn't pretty, this is how it's supposed to look. Okay, we move to the second example. The second example right here says we're going to solve for t. So you can see that it's right here in our equation, and we want to get it all by itself. I'm going to write it right below. And I'm going to show you that this 3 and the t are attached together by multiplication. So we want to do that opposite operation, which is to divide by 3. Whenever we do to one side, we have to do to the other. So we can either divide by 3 right there to the whole thing, or you can distribute the 3 to both. For our purposes today, we just need to divide everything by 3, but you can distribute it to both. On the right side of your equation, those 3's will divide out, and you're left with a t. On the left side, nothing simplifies, so you're left with 5s minus 2 over 3, and that is your solution. Okay, we're going to continue with other problems that are asking us to solve for specific variables. And on this one, I forgot to tell you which one to solve for. So we're going to solve for x. Because this entire thing is already in a fraction, I'm going to go ahead and rewrite it. 4xy over p equals 7, and we want to get rid of the p first. So to get rid of the p, we have to think about what is happening with the p. It's being divided, so we want to do the opposite operation, which is to multiply. Whatever we do to one side, we have to do to the other. And these p's right here on the left side will then divide out, and you're left with a 4xy equals 7p. From here, you're still looking to get x by itself, so we want to pick off the 4 and the y. Now if you notice, all of these are multiplied together. So to do the opposite of multiplying, we will divide, and we can actually do this division here of the 4's and of the y at the same time. So whatever you do to one side, make sure you do that on the other. On the left side, everything divides out except for the x. We're left with x equals 7p over 4y, and that is your solution. Okay, to our next equation, we're going to solve for b. And this is a case where b occurs twice in the equation. Because it occurs twice in the equation, we want to move the smaller one to the bigger one. The smaller one is the 3b, so we want to move it to the other side of that equals. So to move it to the other side, we have to do the opposite of what is happening. Because there isn't a sign on the 3, it's like there's a positive 3 there. And we want to do the opposite, which is to subtract 3b. Sorry, I lost that. So minus 3b on both sides. These 3b's right here will subtract. But notice that this is still a negative 2 over here. And then we'll go ahead and go 5b minus 3b is 2b plus c. Now, we're still trying to get that b by itself. Here we just combined our b's and got them on the same side of the equals. Now our next step is to get rid of that z. So to get rid of that z, it's being added, and we want to subtract z to both sides. These z's will subtract out, and you're left with a 2b on one side. On the other side, they're not like terms, so when they're not like terms, we just put them next to each other. Okay. And again, still looking to get b by itself, and we want to look and see how the 2 and the b are tied together. They're tied by a multiplication, so we want to do the opposite of multiplying, which is dividing. And we're going to use a division line. And whatever we do to one side, we have to do to the other, but I'm going to divide everything. We could distribute it to both, but we don't need to for the purpose that I want you to do here. So these 2's on the right side will cancel. You get b over here, which is what we're looking to get. And on the left side, we get negative 2 minus z all over 2. Okay, to continue on, we go on to what the area of a trapezoid formula is. And it looks like this. Area equals half times the height times base 1 plus base 2. Because those bases are different lengths, we have to somehow account for both of them. So on our example here, I would suggest the first thing that we're going to need to do is to find out which one is base 1 and base 2. In a trapezoid, the bases are parallel. If you look, you can see that the 6 and the 12 are the only two sides that are parallel. So we're going to call this one B1 and this one B2. It really doesn't matter which one is which. And we're going to look to find the area of this trapezoid. So the first thing you do is take 1/2 times the height. The height is how tall the trapezoid is. So we're going to use this 5 as a height. So we're going to multiply this by 5. And then take our base 1, which is 6, plus our base 2, which is 12, and then we'll go ahead and solve this. So area equals half times 5 times 6 plus 12, which is 18. We keep solving this. Area equals half of 5 times 18. We'll multiply the 5 and the 18. 5 times 18 is 90. We're going to take half of 90, which is 40. Whenever we do units, we're talking about, say, units squared. If I had initially told you that 12 was 12 inches, then we would say 40 inches squared. Now back up to the question, it says to find the perimeter of the trapezoid. If we were asked to find the perimeter of this trapezoid, we would need some other side lengths. For example, we would need these two, and since we don't have them, we cannot find the perimeter. However, if I did throw in some numbers, and we did know the two sides, then to find the perimeter, you would just add all three sides. Okay, so example 3 says, if the area of a trapezoid is 48, find the length of the smaller base. So our formula for the area of a trapezoid is area equals half the height times base 1 plus base 2. And we're going to fill in what we know. It says in the formula that the area is 48, so we're going to replace that A with a 48. And then look at our trapezoid and see what we know. This 3 is the H. We're going to call this X, B1, and this 10, B2. So I have 48 equals half of H. In this case it's 3 times B1, which is X, plus B2, which is 10. Now you could guess and check to solve this problem, or we're going to solve it by doing a little algebra. So, to start off with, we want to get rid of that 1/2. To get rid of that 1/2, we're going to multiply both sides by 2 over 1. And when we do that, these 1/2s will divide out, and you're left with 3 times x plus 10. I'm going to have you guys practice the distributive property with this one here shortly. 2 times 48 on the left side is 96. There are other ways to solve this, but I want you to use the distributive property that we talked about at the beginning of the year, or this chapter, which says that we're going to take 3 times the x and 3 times the 10, distribute it to both. So when we multiply those, we get 3x plus 3 times 10 is 30. And then from here we'll solve this problem, and we've been solving problems like this for a little while. So we'll start by subtracting 30 to both sides. So on the right side, the 30s subtract out, and you get 3x equals 66. And then to get that x all by itself, we're going to do the opposite of multiplying, which is to divide. These 3's divide out, and 3 divides into 66 22 times. So now let's come up and look at our trapezoid. We just found out that your B1 had a length of 22. If you look at our trapezoid, it does not look like it matches. Like this side is 22, but this side is 10. So I would say, according to the information that we were given, that the area was 48, that this drawing was done correctly, and we could fix that if we needed to. So I think the last slide says that we are going to write an equation and solve for a variable specified. So this says 15 more than a number equals. I think I've told you to before, whenever you see this equals or is, we're going to circle it and put in equals. And then figure out what goes on the left side. So on the left side it says 15 more than a number. So we have 15 more than a number W. More than means we're going to add. Equals is the product. Product is a key word. It means we're going to multiply. It says we're going to multiply 7 and a number minus 8. Now because this says a number minus 8, I'm going to put, a number x, it in parentheses. Okay, so here we're going to solve for x. To solve for x, I would get rid of that 7 right now. To get rid of that 7, we're going to do the opposite of what's happening. It's multiplying, so we're going to divide both sides by 7. When we divide by 7, these numbers divide out. And you're left with x minus 8 here. On the left side, 15 plus w. And then to get x by, divided by 7. And then to get x by itself, we're going to do the opposite of what's happening with that 8, which is subtracting, so we're going to add 8 to both sides. So these 8's subtract out, you're left with x equals 8 plus 15 plus w divided by 7. And there's your expression. Good luck. Our assignment is our 3-8 specific variables worksheet, and I will see you later.